Okay, good evening, everybody. I'm here for my last day, I think, of subbing for you guys. So someone, presumably in the math department, will reach out to you guys about whatever's going to happen next. So today we're going to talk over a couple of things. We'll talk a little bit more about the chain rule. With my own class, I wound up spending another day on chain rule, actually, because people seem to still have some confusion, especially about when we had multiple chain rules all chaining together. That seemed to be confusing people. So I'll talk a little bit about that. And then we'll learn two more rules, I think the last rules. And then we'll do some practice of doing some of the problems that are going to just involve some or all of every rule. Okay? So let's first review what the chain rule actually says. Okay? What the chain rule actually says is, if I do the derivative of a composition of functions, its derivative will be equal to, hang on, let me erase some of this. This is getting a little bit crazy here. Okay, so I'm talking about the information in this gray box here. It says, if we do the derivative of a composition of functions, f of g of x, then its derivative will be the derivative of the outside function, where we plug in the original inside function. And then we're going to multiply by the derivative of that inside function. Okay? That's how this chain rule stuff works. And I don't want you guys to get too attached to the letters here, okay? The letters here are just random letters. We could use K and J, or we could use S and T. All right, whatever letters we want to use. What I want you guys to remember is the form of what's going on here. We have one function being plugged into another function, and what I want you to remember is we do the outside derivative first, and then we plug in the original inside function, and then we multiply by the derivative of the inside function. That's how I want you to remember the rule. So let's do a quick warm-up. Let's try ln of q squared plus 1. Okay, so we'll do this the long way first, and then I'll show you the kind of short way. The long way is to go through all three of the steps that we talked about last time. To remind you, those steps were, first, to figure out what is the inside and the outside function. And then it was to figure out the derivatives of those functions. And then it was to kind of plug everything in to the formula using all of that information. Okay, that was what we did. So let's start with ln of q squared plus 1 by identifying what is the inside and the outside function. So if this is f of g of x, my question for you guys is, what is f of z and what is g of x? G of q. Can anybody give me one of those? Yes?
For ln and b, 1 over d. So this sorry.
Getting a little bit ahead of ourselves.
Just ln.
Yeah. Which one? G or F?
F.
Yeah, in our case, the outside function is ln of z. Thank you very much. Now, I want to look at this function ln of q squared plus 1. What we've now said is, okay, this is some function being plugged into the function ln of z. Okay? My question now is, what is g of q? G of q is going to be the function which is being plugged in. Can anybody tell me what that function is? Yeah, q squared plus 1. Thank you. Okay, so we identified the inside and the outside function. Now it's time to take the derivative of those functions. We already heard that the derivative of ln of z is just going to be 1 over z. And the derivative of g, we just use the power rule, it's going to be 2q. Great, so like before, this was like our blue box, I guess, is what we called it. And it has all the information that we need to do the derivative of f of g of q. So if we want to do the derivative of f of g of q, the formula should be derivative of the outside function, where we plug in the original inside function, and then we multiply by g prime of q, the derivative of the inside function. So what I do is I take g of q. It's not 2q. That is q squared plus 1. And I plug that in to f prime. That's 1 over z. And I get 1 over whatever g of q was, q squared plus 1. And I multiply by the derivative of g, which is 2q. So my final answer would be 2q over q squared plus 1. All right. So that's the standard application of the chain rule. Usually we don't go to such great lengths to write out what f and g and f prime and g prime are. Once we get really comfortable with the chain rule, the way we're going to do it is just by kind of automatically recognizing, okay, I see that this is a composition of functions. I know by the chain rule, first I should just do the derivative of the outside function and leave the inside function alone, and then multiply by the derivative of whatever's inside. So the way that I would do that is I'd look at this and say, okay, dy dx, that's the same way of saying f prime. dy dx, that's just going to be equal to, 1 over q squared plus 1. That's where I just, did the derivative of ln and left q squared plus 1 alone. And then now I'm going to multiply by the derivative, which I get from having to do the chain rule of this q squared plus 1. And that's just the derivative of that thing, which is 2q. Okay, so that's how you might do it once you're really comfortable with the chain rule. Can you put your mask over your face, please? Yeah. Thank you. Okay, so any questions about this warm-up problem here? Okay. Let's try f on our own, okay? So I'll give you guys a couple minutes to try and do f. We want to figure out what is the derivative of this thing. So ultimately, we want to write g prime of x, okay? So you can do it any method that you want. If you want to do it the quick way and you think you're familiar with chain rule, you can test yourself and try it out. If you feel like you still need more practice getting familiar with it, then go ahead and write out what the inside and outside functions are and so on and so forth. Find your derivatives and plug into the formula, okay? right, please raise your hand if you're finished with the problem. Okay. Those of you who didn't raise your hand need a little bit more time, or are you guys stuck? Stuck? Okay. Let's go through it together then. Okay, so if we want to take the derivative of this thing, all right, we've kind of got two pieces. All right, doing the derivative of this plus 17 part is not going to be too hard. What's going to happen to that? Yeah, it'll just be 0. So I'm just going to write plus 0 here. And now I think the hard part is figuring out what is the derivative of e to the negative x squared. Okay, let's go through the whole composition thing to sort of make this very clear. So my point is, I have e to the minus x squared. It is a composition of functions. Okay, I can identify that this is a composition of functions because I can see that it's kind of like this negative x squared function is being plugged into some other function, e to the z. Okay, so anytime that we see a power looking kind of funky like this, that's a cue that we might want to use the chain rule, okay? Because if our power is itself a function, then that's our cue that that's a composition. Okay, so we want to write this as, I don't know, how about P of Q of X? And then we know that if we do the derivative of that, so let me move that down a little bit. If we wind up doing the derivative later on, when we do the derivative of P of Q of X, we know that's going to be equal to, what should go on the right-hand side of this equal sign? Something with P and Q and the derivatives thereof. Does anybody know the formula? So this comes from the chain rule, right? The only thing that we've changed now is the letters here. What if it was f of g of x and we wanted to do that derivative? Can somebody give me the formula of what the right-hand side would look like? Yes?
So it'll be p prime times q of x.
Not times, but of.
Oh yeah, oh, sorry.
Yeah.
And then multiplied by q prime of x.
Exactly right. Okay? This looks just like, you know, the way we write it usually is with f and g, and we write f prime of g of x times g prime of x. Okay? The only thing that's different here is I'm using different letters. I'm using p and q instead of f and g. And so I can just remember this formula here. And when it's time to do the derivative of p of q of x, what I'm going to do is I'm just going to say, okay, everywhere I see an f, I'm going to put a p. Everywhere I see an f prime, I'm going to put a p prime. Everywhere I see a g, I'm going to put a q. And everywhere I see a g prime, I'm going to put a q prime. Do you guys see the relationship between these two equations that I put green dots next to? Do they look similar? Okay. It's just a difference of what I'm calling the function. Okay? It's just like how you guys might call me Tom. You might call him Riley? You might call him Riley. You know, it's just a different name for this, for something, okay? And we could switch it up. You could call me, instead, you could call me Thomas. You could call him, I don't know, Mr. R. or something like that, right? It's just a switching up of what we're calling things. That's all that's going on here. Okay, I'm going to erase this middle thing here because that was just to help us remember how we should get the derivative of p of q of x. Okay, so we have the formula for what things should look like in the end, and what we need to do first is figure out which one is the inside function and which one is the outside function. Okay, so we should write p of z is something, and q of z, x, is something else. So what do we think q of x is, the inside function?
Negative x squared.
Yeah, negative x squared. Very good. It's just the function that's in the power. Okay? Your power is pretty much always going to be your inside function if you have an exponential problem like this. All right, and what should p of z be?
E to the power of z plus 17.
I'm glad that you made that point here. Okay, we have this 17 kind of floating around here down in the actual problem. I already sort of took care of it. We don't need to actually include it in our chain rule thing. Here's why. The sum rule says that if I want to do the derivative of g of x here, what I can actually do is just do the derivative of e to the minus x squared and then do the derivative of 17 and then add those two things. Okay? That's what the sum rule says. So I already took care of 17. And now all I'm trying to do is just the derivative of e to the minus x squared. So when I wrote e to the minus x squared equals p of q of x, I left out the 17 just because it's going to make it a little bit easier for us to write a little bit less. So I'm really glad that you brought that up. So if our p of q of x is just equal to e to the minus x squared, and q of x is minus x squared, what's p to the z? Or p of z, excuse me.
E to the power of z.
Yep, just e to the power z. We don't need the 17. Okay, so now we're going to go ahead and take the derivative of those two things. What's p prime of z? Yes?
It's the same thing.
Same thing, e to the z. What's q prime of x? Yes?
Negative 2x.
Exactly, negative 2x. Okay, I used two rules there. One rule that I used was multiplication by a constant. You can think of this minus sign out front as being multiplying by negative 1. So the minus sign just kind of hung out, and then I wrote down what is the derivative of x squared? It's 2x. So the minus sign just comes along for the ride. Okay, all together now. Let's plug it in. I want to take regular q, that's minus x squared, and plug it into the derivative of p. So I'm just going to plug this x squared right here. I'm going to plug it in to the function e to the z. And I get e to the minus x squared. Now I need to multiply by q prime of x. That's negative 2x. Okay, so now I figured out what the derivative of e to the minus x squared was. I need to now incorporate it in g prime of x. Because remember, g prime should be the sum of the derivative of e to the minus x squared and the derivative of 17, which we already computed was 0. So I'm just going to take the derivative we just computed, and I'm going to put it in this spot right here. It's going to be e to the minus x squared times negative 2x. And that's my answer. Okay? So there will be times when we might have to use the chain rule on different pieces of a sum. Okay? In this case, we had a derivative of a sum, which we said that the derivative of a sum will be the sum of the derivatives. So I treated 17 and e to the minus x squared on their own, and then I just added those two things together. Okay? Any questions about the process? No questions? Okay. Well, let me maybe go through this how I would do it. And I'll give you the quick version again so that you can start to see kind of the thought process of how doing chain rule quickly kind of goes. Okay, so I'm going to erase all this stuff. And I'll show you what I would do if I was doing this. Okay. First thing I would do is just kind of recognize that this first thing is a composition of functions, okay? And I'm going to just treat, when I do g prime of x, I know that this is a sum of functions, so it's just going to be the sum of the derivatives. I'm going to write plus 0 out back because I know that 17 is just going to go right away. And now what I'm going to write in here should be the derivative of e to the negative x squared. Now I know from seeing countless chain rule problems that this is a composition of functions. I can see that the function negative x squared is being plugged into e to the z. And I know that what I should really do here is just treat this whole thing like z at first and just do the derivative of that. So what I would get is e, and then I would just keep whatever's up there because the derivative of e to the z is e to the z. So I would keep negative x squared up here. And then just to keep my notation nice, I might, do one of these things. I'll put this little arrow here to show that since negative x squared was being plugged into this function, I should chain rule out when I do the derivative. So then I would write here the derivative of minus x squared, which I know is negative 2x because of the power rule and the multiplication by constant rule. And then I'm done. So that's the fast way, which once you start recognizing the form of all of these chain rule problems, you'll start getting the hang of these, and you'll start seeing the way that these things are computed, and it'll become familiar. Okay. Let's do this one. 4t squared. Hang on. Are there any questions about the fast way or the slow way for this problem? I feel like there's not a lot of questions, but I'm sensing a bit of confusion out there. If you're confused, could you help me by verbalizing the part that is maybe the most difficult to digest?
I get it now. That made more sense than the explained it.
Okay. Anyone else? All right. Let's go on to this one then. We'll do the derivative of 4t squared plus 1 all to the 7th power. Let's do it the fast way together. Let's just, in our minds, keep track of what is the inside and the outside function. So let's just think for a second. If we have y equals 4t squared plus 1 to the power 7, what's the inside function here? 4t squared plus 1. It's all of this stuff here that's in these parentheses. That's my inside. And then the outside function is, yeah, z to the 7th power. Okay, so the way I'm going to treat this is I'm going to use the kind of fast way. What I'm going to do is I know that the inside is an inside function, and I know when I do the chain rule, what I should do first is the derivative of the outside function and leave the inside just totally alone. Okay, so I'm going to treat this as if it was one big variable z. Okay, that's how I'm going to treat it. If I was going to do the derivative of z to the 7th power, I would just use the power rule, right? I would get 7, and then where I had a z, I'm going to write the actual equation, 4t squared plus 1, and then the power should be 6 now. But I should remember that since the inside was a function itself, I should multiply by the derivative of that function, which is 8t. Starting to become more clear?
Why is it 8?
Great question. When I did the derivative of 4t squared plus 1, the 1 is a constant, right? So when we do that derivative, it just goes away, right? And what about 4t squared? Which rule should I use? Power rule, right? So the power 2 came down front and got multiplied, and then we made the power 1 less. So I didn't write it, but there's kind of like a t to the power 1 here. Let me make sure that's extra clear. That's a 1. So that's where that 8t came from. I just multiplied 2 times 4, and I took away 1 from the power. We usually don't write it if it's a power 1. We just leave it like that. Other questions about how I did that? I think it'll be beneficial if I do another example, maybe. Let's do this one. All right. I'm going to do it a little bit quicker this time. 5 ln of 2t squared plus 2 plus 7t squared minus 9. Okay, I have a sum of 3 things. If I do the derivative of a sum, I can just do the derivative of each summand, right? Where this is a summand, and this is a summand, and this is a summand. The 2 on the right are fairly easy to do, okay? Let's write them down right away. F prime of t is going to be, I don't know, something nasty, and then 14t plus 0. Okay? Where 0 was the derivative of 9, and 14t was the derivative of 7t squared. Did I do this problem last time? I feel like I might have done this problem already. Oh well, if nobody remembers it, then we'll keep doing it. Okay, so now I need to just do the derivative of this last summand. It's 5 ln of 2t squared plus 2. What's the inside function here? Exactly, 2t squared plus 2. And for the time being, I'm going to treat that whole inside thing as like z. Okay, just for the time being. Now, if I were to do the derivative of 5 ln z, what would I get? Yeah, 5 over z, because the 5 would just hang out, and then the derivative of ln z is 1 over z, so if we multiply 5 times 1 over z, we'd get 5 over z. So I'm going to write 5 over, except I'm going to be careful here, where I see a z, I'm actually going to write 2t squared plus 2. And now I need to remember that I should chain rule out the derivative of that function z, because z is itself a function. So what should go in this blank spot here? We should multiply by,
14.
yeah, 4t. Is that the same thing that you had?
Yeah.
Okay, great. So altogether, if we wanted to write it nice, we'd get like 20t, actually we'd get, yeah, 20t over 2t squared plus 2 plus 14t, which is the same thing as 10t over t squared plus 1 plus 14t. All right? So like I said, it's a little bit cumbersome to do the whole process of writing down, okay, this is the inside function, and this is the outside function, and this is the derivative of the outside function, and the derivative of the inside function, and then write down the formula, and then plug everything into the formula. It takes a little bit of time. It is great for demonstrating the rule when you start, and it's good for practicing the rule when you start. After a while, you start to recognize the process that's going on here for what it is, and you get the hang of doing things quickly. Any questions about this problem? Seriously, welcome any and all questions. Set to move on then? Okay. I want to talk about one more thing. Which is when I have the composition of more than two functions. When I have three functions all being composed. Here's an example. F of x equals e to the power x squared plus 3 to the 9th. Okay, this is a composition of three functions. Okay, this is a composition of three functions. The bottom layer is x squared plus 3. Then I'm plugging that function in to the function z to the power 9. And then I am plugging that function into the function e to the y. Okay, I have a function being plugged into a function, and then I take the result of that and I plug it into yet another function. So I could write this as g of h of k of x where k of x, the innermost function, is x squared plus 3. Someone tell me, what is h of z? Z to the power of 9. And the bottom function, g of y, we'll make it y. No, let's not use y, let's use t. What's g? Close. G is a function of t. So if g is a function of t, you have the right function. Yeah, but the wrong variable. It should be e to the t. Ah. What is this doing here? Get out of here. E to the t. Good. So, I'm going to show you real quick how this would work if we wanted to really go ahead and compute, k prime, we could compute h prime, we could compute g prime, and all of those are going to be in our, blue box. And then I'll tell you that the derivative of g of h of x, of k of x, if we want to do the derivative of this thing, it'll be equal to, it's just the same thing that we usually do, okay? I'm going to treat this whole inside thing here as its own function, and I'm just going to use the chain rule. The chain rule says, derivative of the outside, leave the inside alone, then multiply by the derivative of the inside. So I'm going to write g prime of, I'm just going to leave the whole inside alone, h of k of x. Now, what I should multiply by should be the derivative of the inside, except the inside is again a composition of functions. So if I want to do the derivative of h of k of x, I should use the chain rule. The chain rule says, well, h is the outside function, we do the derivative of h first, and we leave k alone. And then, finally, we should multiply by the derivative of the inside, which is k prime of x. Okay? So two chain rules happened. Okay, we have a total of 3 functions, 2 compositions, and 2 chain rules to do this derivative. Now I'll show you how I do it in practice. Okay? Here's how I do it in practice. I would look at this, and I would say, okay, f prime of x is gonna be, well, I'm gonna treat all of this thing, by which I mean I include the 9 here, the 9th power, as my z. So I'm just going to rewrite e to the whatever that thing was before, x squared plus 3 to the power 9th. And now, what needs to go in this blank should be the derivative of x squared plus 3 to the power 9. Now, it is again a composition of functions. So I'm going to treat now, I'm going to treat I want to write the derivative, I want to color code this right. Okay, I want to write the derivative of this function here in this blank. But I need to treat all the way the inside, this whole thing, as z, and I treat the function as z to the power 9th. So now what should go here should be 9 times, leave the inside alone, to the power 8, and now I should take the derivative of this thing and multiply it out here. So then it should be times 2x. Okay, that's how this happened. So I wound up with e to the x squared plus 3 to the power 9th. That came from doing the derivative of e to the z and just plugging in the original inside function. And then I multiplied down by the derivative of the power. But the derivative of the power was itself a chain rule problem. So its derivative was all of this, where everything that's underlined in green is the derivative of the function which is in the power. All right, questions? A lot of layers. It's like an onion. Okay. or an ogre. All right, so no questions about the chain rule, double chain rule problem? All right, well, we're gonna move on and learn something new then. We're gonna learn two more rules called the product rule and the quotient rule. And I don't know if I would say that they're easier per se. The product rule is pretty easy. It's just a memorization thing. And then the quotient rule is also kind of a memorization thing. Although, if you really don't want to learn the quotient rule, you don't actually have to learn the quotient rule. You can just use the product rule and the chain rule. Maybe I'll show you that proof here in a minute. But first, let's talk about the product rule. So what the product rule says is, if I have a problem that tells me to do the derivative of f of x times g of x. So I have two functions that aren't being composed, they're being multiplied by one another, okay? Two functions being multiplied by one another. Then the derivative will be f prime of x times regular g of x plus regular f of x. Didn't write it regular. Regular f of x times g prime of x. Okay, so if you remember one thing from today, let it be that the derivative of a product of functions is not equal to the product of the derivatives. Okay? We have a rule that says, okay, well, if you do the derivative of f plus g, then all you have to do is just, that's just the derivative of f plus the derivative of g. That's very nice. It's not true if we multiply f and g together. We can't just take the derivatives individually and then multiply them. We don't get the derivative if we do that. Okay? What we should do instead is take the derivatives of f and g and then plug them into this formula where we have to take the derivative of f times regular g and then we add regular f times derivative of g. That's what the product rule says. So let's have an example here. We have here f of x is a product of two functions. Okay? Let's make it, I want to make this h of x. Okay, let's erase this. This is going to be h of x for the purposes of, we're using the rule, okay? So, step one with the product rule problem is kind of similar to step one with the chain rule problem. The chain rule, what we wanted to do first was identify the inside and the outside function, right? What we want to do first with a product rule problem is identify the two functions which are being multiplied together. We want to kind of separate them out so that we can treat them individually. So what I want to write is h of x is equal to f of x times another function g of x. And I want f of x and g of x to be functions that I know how to do the derivative of. So my question is, what is f of x and g of x? Can someone give me one of them? Yeah, f of x is x squared, and then, well, g of x is just going to be the thing that x squared is being multiplied by, which is e to the power 2x. Much like before, if we want to use the product rule here, we got to figure out what f prime and g prime are going to be. And then we're going to have our whatever little blue box pantry thing, and we just use the pieces of it to plug into our formula. So what is, I'll draw a little line here. What is f prime of x going to be? 2x. That was the easy one. What about g prime of x? Yes, very good. By the chain rule, it will be e to the 2x, except what you just did here was you treated 2x as like your z, okay? That's what's going on here. So now we need to do the derivative of the inner function. So I multiply by 2. Great. Very good. All right. So we found f prime and g prime. Now all that's left to do is use this formula. Okay, it says I should take f prime of x, and I should multiply that times g of x. And then I should add regular f of x and multiply that times the derivative of g. So, the first step here, f prime of x times g of x. I want to take these two functions and multiply them. So I get 2x times e to the power 2x. Next step, I need to take f of x times g prime of x. So I'm going to take these two functions and multiply them. And I'm going to get plus 2x squared e to the 2x. Gotta rearrange things a little bit there. And that's it. That's the product rule. So, if I have a product of functions and I want to do their derivative, it is not equal to just take the derivatives and multiply them. That's the takeaway here. So if we were going to make things consistent with how we've been doing it, this right here is kind of like our blue box. Only instead of plugging functions into other functions, we're taking functions and multiplying them by one another. Okay, let's have some thumbs. How do we feel about the chain rule? Thumbs up for this is so easy, thumbs down for this is pretty hard, and somewhere in between for somewhere in between. Okay, I'm seeing some thumbs up and some thumbs in between. So let's do another practice problem. Yeah, let's do another practice problem. Oh goody, here's one where we can use the product rule and the chain rule again. Before we go on, is there any questions about this first problem on the product rule? I should say, are there any questions on this part of the product rule? No? Okay. Then let's do this next problem. I have y equals t cubed times ln of t plus 1. Is this a product of functions? Hands up for yes, we think it's a product of functions. Hands down. Hands up for if we think no, we're not sure that this is a product of functions. Okay, good. Everybody thinks it's a product of functions. It is a product of functions. Can someone volunteer to tell me what the two functions are besides the two people? Oh, in the back, yes.
T cubed ln and t plus 1.
You're close. You're close. So the suggestion was to split it up right here with this line right here, and everything to the left is one function and everything to the right is another function. Do we agree? Sorry, go ahead.
Is it not that?
It's not quite that.
Is it t cubed and then ln t plus 1?
Yeah, that's what it is. It's t cubed and then ln of t plus 1. That's what it should be. Okay, so the reason that we should keep the ln with the other stuff, by the way, is because t plus 1 is sort of inside of the ln function. So what we should think of is not that these parentheses don't go with t plus 1. The parentheses go with ln, okay? So the way that we should think about it is like, that's not right, like this. So this is kind of like a package deal, the ln and the parentheses. And it happens to be that t plus 1 is on the inside here. Okay, great. Thank you for volunteering. So these are going to be our functions. So we have f is t cubed. G is ln of t plus 1. Draw a little line here. What is f prime?
3t squared.
Very good, 3t squared. What is g prime? Yeah, 1 over t plus 1 times 1. Why times 1? Yeah, the derivative of t plus 1. Okay, this was an application of the chain rule, where the inner function was t plus 1. So we do the derivative of ln, and we put the entire inside function into the derivative of ln, and then we multiply by the derivative of that function. Fortunately for us, it was just 1. So we could even get rid of this times 1 here. We can just write it 1 over t plus 1. Great. All right, so what I'm going to do is I'm going to multiply crisscross style and then add. So first comes f prime g, and then I'm going to add f g prime. That's how I'm going to do it. So it's going to be equal to 3t squared times regular g. And then I add. Now I should have regular f, that's t cubed. And I should multiply by the derivative of g, that's 1 over t plus 1. So altogether I get 3t squared ln of t plus 1 plus t cubed over t plus 1. Any questions? You guys like the chain rule or the product rule better? Product rule better? Clicks with you a little bit better? Yeah, I think students don't really like compositions of functions as much as multiplying them. Did you have a question?
Yeah, how did you get, I know there's a way to, but how did you get t cubed over t plus 1?
So yeah, I simplified here. So on the left side of this equals sign, I had t cubed times 1 over t plus 1. So what I can do here is I can rewrite t cubed as the fraction t cubed over 1. And then if I want to multiply fractions, I just multiply straight across. So t cubed times 1 got me t cubed, and then multiplying 1 times t plus 1 got me t plus 1. Thank you for asking. So yeah, I simplified that. That's all I did. Okay. So let's learn our next rule. I think this one you guys are not going to like. Or if you You might like it a little bit more than chain rule, but probably not as much as product rule. So let's learn it. The rule is how to do the derivative of one function divided by another function. That's what a quotient is, right? The quotient is the result of doing division. So if we want to do the derivative of one function f of x being divided by another function g of x, we get a big nasty formula. Are you guys ready? It is g of x times f prime of x minus f of x times g prime of x, all divided by g of x squared. All right, kind of a nasty looking thing. There are ways to remember it. The one that I hear the most often is people call this bottom function, they call it low for being lower than the other one, and they call this top function high. And what they say is that this is just low d high minus high d low all over low squared. So low d high minus high d low over low squared. That's one mnemonic device that people have for it. By the way, the order here matters, okay? If we flip these guys up, we're going to get the wrong answer. Unlike in the product rule. If we flip things up in the product rule and do this backwards, we're going to be okay, because guess what? 3 plus 6 is the same as 6 plus 3, right? If we add two things together, it doesn't matter which order we add them in. If we do 3 plus 6, we get 9. If we do 6 plus 3, we get 9. However, it's not true for subtracting things. If we do 6 minus 3, we get 3. But if we do 3 minus 6, we get negative 3. Two different answers. Okay? So the order that we do this in does matter. You need to make sure that you do g times f prime and then subtract from that f times g prime. Okay? So the order does matter. One way that I heard a student remember this was like, oh yeah, I have a girlfriend, GF, and she's totally prime, so GF prime. That's how they remembered it. I don't know. If that works for you, great. If the low-D high thing works for you, also great. But you do need to remember that G times F prime is what comes first in this subtraction here. All right, let's do a practice problem. So we'll try it out on this function here, which again, I'm going to switch the letter and make this h of t. So I want to say that this is equal to f of t divided by g of t, right? So in particular, f of t is equal to the top function, high. It's e to the 2t. And the bottom function, g of t, is equal to t. Now, just like the other rules, we're going to first compute what is f prime and what is g prime, and then we're going to plug everything into the formula. So, write a little line here. What's the derivative of e to the power 2t? I've had somebody help me with many chain rule problems. Let's have somebody else. Anybody confident with what the derivative of e to the power 2t should be? Or have a good guess?
Is it 2e to the 2t?
Very good. It should be 2e to the 2t. Or e to the 2t times 2. Right? In this case, you put your chain rule multiplication down in the front. That's fine. All right, and g prime of t is just going to be 1, right? It should just be 1. Okay, now we plug into the formula. We get h prime of t. Remember, we should do g times f prime first. So, t times 2e to the 2t. That's what comes first, then a minus sign. What comes second should be f, regular f, times derivative of g. That should be e to the 2t times 1. And then we divide everything by g squared. What is g squared? T squared. G of t is t, so if I take that function and I square it, it'd be the same as multiplying t times t, and I would get t squared. So that's the quotient rule. Does anybody hate the quotient rule? Yeah. Some shrugs, some no's. Okay. I could teach you a way that you never have to learn the quotient rule, but I think you're gonna dislike that method even more because it involves the chain rule and the product rule together. Okay, maybe I'll show you really quick. It won't take very long. So, how to never learn the quotient rule. The way to never learn the quotient rule is to recognize that f over g is the same as f times the function 1 over g, which is the same as the function f times g being plugged into the function z to the negative first power. So, if we wanted to do the derivative of f times g to the negative first power, we could treat this as the derivative of a product of functions, f and h, where f is just f and h is g to the negative first power. Well, the derivative of a product would just be, how did we write it? Which one did we write first? Can't remember. F prime g. So f prime times h plus f times h prime. That's what we would get. So if we let f equal f and g equal, h equal g to the negative first power, then f prime is just f prime, and then h prime would just be negative 1 times g to the negative 2 times the derivative of g by the chain rule. So I treat g as the inside function, and I just say, okay, I have some function to a power. I use the power rule, leave the inside function alone. The old power comes down front. I subtract 1 from the power, so negative 1 minus 1 is negative 2. And then I multiply down by the derivative of the inside. And so then I would just I would get f prime times, well, h is just g. And then I would add f times h prime, which is f negative f times g prime all over g squared. And if we got a common denominator, it would be gf prime minus fg prime all over g squared. So that is how to never do the quotient rule. It's actually how the quotient rule was discovered. All right, I don't really recommend learning that as a way to avoid the quotient rule. I think it's going to be faster and easier for you to just memorize the quotient rule. But if it really trips you up, you can't always do this. And this is a good demonstration of the principles of doing derivatives. All right, let's do some more practice. Let's try this function, f of x equals 1 over 1 plus e to the x. Well, let's start by identifying which rules do we think we're going to use to do this derivative. We're talking about this one. Yeah, quotient rule probably, or I can do the thing that I just did, but I'm not going to do that. Okay, what's the top function? So if this is g of x divided by h of x, then my question to you is, what is g of x and what is h of x? Any ideas? I know I'm switching up the letters on you again, aren't I? G of x is just the top function, right? So what should it be? Yeah, 1. And h of x should just be the function that's on the bottom. 1 plus e to the x. Okay, now we compute the derivatives. What is g prime of x? 0. And what is h prime of x? Just e to the x. Very good. All right. Now, I want to write down what is f prime of x. I know it's a quotient rule, so it should be a fraction. So who remembers if I have high and low, which one comes first? I should have a subtraction sign here. Which one comes first? Yeah, low d high comes first. In our case, low is the function h. So we should leave h alone. If we have low d high means do the derivative of the high function, right? So first I leave low alone. That's 1 plus e to the x. And I should multiply by d high. Well, d high is derivative of the top function, which is g prime of x, which is 0. And now I subtract from that high d low. the top function, the high function, is 1. And then d low will be the derivative of the denominator. So that's just e to the x. And on the bottom here, what should we have in terms of high and low? Low squared. So low is the function that's on the bottom. It's 1 plus e to the x, so I'm just going to plug that in and square it. 1 plus e to the x, all squared. All right, that's how I do that problem. So my final answer would just be e to the x over, if I FOILed that out, I'd get 1 plus 2 e to the x plus e to the 2x. That would be my answer. Yeah, thank you. It should be negative. Very good. All right, I got 2 minutes. I'm going to do one more problem. We'll do this product rule problem. Should go pretty quick. All right, g of x is a product of functions. What are the two functions being multiplied?
X squared plus 5x and e to the x.
Perfect. So here's where I should draw my line. Great. So if I want to do the derivative, what I should do is call this thing f, call this thing g. Well, then f prime is going to be equal to 6x plus 5. And g prime will be equal to just e to the x, right? So I should take f prime g, and then I should add fg prime. So my answer is 6x plus 5. I should have made this an h again. So h prime of x is 6x plus 5. Need to remember to put parentheses around that. Times g, that's e to the x. Now I add. Now should come regular f multiply by derivative of g. Now we have a common factor here of e to the x. So we could pull it out as a GCF. We would get this is equal to e to the x times, what we would do is we would just take what's in these parentheses here and add them. So we would get 3x squared plus 11x plus 5. That might be our answer. Okay, we're done with class for today. If you have questions, stick around after class. Otherwise, it's been a pleasure. You too.
Thank you.
Yeah, of course.